Today we're going to solve absolute value inequalities. So as we've talked about before, the absolute value means the distance a number is from 0 when you consider a number line. So because of that, when we talk about distance, distance can always be positive or it can be 0. So we can have a distance of 0 or distance has to be a positive number. The solution to an absolute value inequality is going to be a compounded inequality. So that means we're going to get two answers, and there's two different ways this can happen. When we have absolute values that are less than equal to, then our compound inequality is going to be an and statement. So we sometimes use the phrase less than, kind of a play on words there, to help remind you that if it's less than, then it's an and. So in this case, I have the absolute value of 5 is less than 5. So I have to ask myself, well, what types of numbers can create the absolute value of 5? Well, it could be -5 inside there, or n could be +5 inside the absolute value. So we write that as a compound statement. So I write it like this: -5 is less than n, which is less than 5. And then we show that as a graph. So on my number line, I would mark -5, you put 0 on there, and +5. And we're going to use open circles because our inequalities are just less thans. And then we're shading the between. So n is going to be bigger than your -5, but it's going to be less than the +5. It's between the two. So I shade here in the middle. Okay, the other type is when I have a greater than. So one of our little phrases, greater, is a play on words, meaning that if we have greater than, it's an or statement. And so our inequality, still we know that the inside is going to have to be 5 or -5, but the arrows are going to point the other direction. So what types of numbers then are greater than that? So I know that -5 is greater than n, or n is greater than +5. And so for graphing purposes, I kind of go ahead and flip this around so you can see better, is n is actually less than -5. So on my number line, I graph -5, I graph +5, and 0. Again, I'm going to put open circles because we're not equal to. This time though, with n being less than -5, it's going to be on the outside, pointing out. And then n greater than +5 is going to be on the inside, pointing to the right. Now, when I see this, the reason or is being used is because there are no common numbers that are less than -5 and then or that are greater than +5. There are no common numbers in here. Where here, these numbers are in common. The numbers that are between -5 and +5 are the same numbers. So those are ands. Okay, so to solve these inequalities, we're going to just begin by peeling away layers in the same way that we did when we solved equations. The first thing I want to make sure I do, though, is to get the absolute value all by itself first. So in example 3 here, the absolute value is by itself. So now I just need to work on just this inside piece. And so the way we like to set this up is we're going to take this value. We already said it could be -30. And then using the same arrow, the same direction, is less than 14 minus 2x. And because it's less than, we could say then that 14 minus 2x is also less than +30. And now we're going to go ahead and solve. So let me start on the left side first. I'm going to go ahead and subtract the 14 And actually, whatever I do there, I'm going to do the same steps on this side. So negative 44 is less than negative 2x. Negative 2x is less than, positive 16. Okay, then my next step is to divide by negative 2. Now at this point, because I'm dividing by a negative, I'm going to go ahead and bring this down. Let me bring this over here also. Negative 8. Okay, because I'm dividing by a negative, we have to flip the inequality arrow. So my inequality switches directions. But take a look what happened. Even though it switched directions, now I have a positive 22 and a negative 8 here. So when I graph on my number line, negative 8, positive 22, they're both open circles. So I want to make sure they're on the right side of 0, basically, on the correct side of 0. And then if it helps, we can flip this one around if that helps you think about what's going on. So it's really x is less than 22 and x is greater than negative 8. So the numbers that are less than 22 and greater than negative 8 are going to fall between these. So even though we switched the arrow, it's still an and statement because we started with the less than in the beginning. Okay, so here's my solution, and then there's the graph of the solution. Okay, let's try number 4. Top of the next page. Okay, so before I can separate this out, I need to go ahead and peel the layers away until I get the absolute value by itself. So let's do those steps first. So I look at all the possible things. I want to get this absolute value here all by itself, this alone. So the first thing I want to do is add the 16. Negative 3, absolute value of x plus 9 is less than negative 42. Okay, the next thing I'm going to do is divide by negative 3. So the absolute value of x plus 9 and negative 42 divided by negative 3 is going to be 14. And because I divided by a negative, right here is where the inequality changes direction. And then the negative divided by negative is positive. Okay, so down to the point where my absolute value is all by itself. So now I'm going to go ahead and separate this out. So I'm going to take the inequality. Now this is a greater, so I know it's going to be an or statement in the end. So I have negative 14 greater than x plus 9, or x plus 9 is greater than positive 14. We're always going to put the negative value on the left. Now we're going to go ahead and do our subtraction. And negative 23 is greater than x, or x is greater than positive 5. And then what helps is to go ahead and switch this one around if it makes you feel better. So x is less than negative 23, or x is greater than 5. So there's our solution. And then we can graph that solution. So I have negative 23. I have positive 5. Again, we have open circles for these because we're just greater than, less than, not equal to. And then the or, x is less than negative 23, so I'm going to graph to the left. And x is greater than positive 5. So I'm going to graph to the right. I'm going to throw a 0 in there. You can. Okay. Then we have some special cases. So I look at number 5 and number 6. So let's go ahead and peel the layers away first. So we're going to go ahead and divide first by the 4. I get the absolute value of x plus 5 is less than negative 8. So this time, remember when we solved equations for absolute value equations and we had an absolute value could not equal a negative number. So at this point when we had equals and a negative, we said that the answer was no solution. But this is a little bit different because I'm looking at this, I'm saying, okay, the absolute value has to be less than negative 8. But what types of numbers are smaller? What numbers are less than negative 8? Well, those are other negative numbers, other negatives. So if other negatives are smaller than negative 8, is it possible then for an absolute value to ever equal a number that is less than negative 8? No, it's not possible. We can't be there. So the answer, the final answer for this particular problem then is no solution. So you might just make note to yourself over here. That occurs when you have the absolute value of a number that is less than a negative number. Then you get no solution. Okay, how about the second special case? Well, take a look at this one. Now I'm saying that the absolute value needs to be greater than a negative number. Well, what types of numbers are greater than negative numbers? Well, there's some negatives that are greater, but also 0 and all of those positive numbers. 0 and all positive numbers are greater than negative 11. So it could be any positive number that's going to be that solution. So that means then the solution is all real numbers. That's my answer. All real numbers. Every number possible because I'm not limiting it. So in that case, if x is greater than a negative number, then my answer is going to be all real numbers. Okay, plan to do more practice with this in class tomorrow with your teacher. Have a great evening.